For centuries, we have looked at Jupiter as the king of our solar system. Massive, unyielding, constant. We thought we knew its measure. We were wrong. In February 2026, NASA revealed something hidden inside this gas giant that changes everything we thought we understood. And what they found is forcing us to rewrite the story of not just Jupiter, but of every planet that ever formed. For over 50 years, our picture of Jupiter came from a handful of measurements taken in the 1970s. The Pioneer and Voyager missions gave us our first close-up views. And from those, we built our models. We calculated Jupiter's size, its shape, its gravitational field. These numbers became the foundation of planetary science, used to understand not just this giant, but gas giants across the universe. We believe Jupiter was 143,000 kilometers wide at its equator. We believe its poles were exactly where they should be. But these numbers were built on limited data, just 6 radio experiments from missions that flew past half a century ago. Jupiter had other ideas. In 2011, NASA launched a spacecraft unlike any before it. Juno was designed not to simply fly past Jupiter, but to orbit it, to dive between the planet and its deadly radiation belts, to peer beneath the clouds, to measure what no one had ever measured. Using an instrument called the radio occultation experiment, Juno did something the earlier missions couldn't. It sent radio signals from behind Jupiter, allowing them to pass directly through the planet's atmosphere. As those signals bent and slowed, they carried with them the secrets of Jupiter's shape, its gravity, its winds. And when scientists at NASA and Israel's Weizmann Institute crunched the numbers, they found something astonishing. Jupiter is smaller than we believed, only by a few kilometers, you might think. But in the precision of planetary science, those few kilometers matter more than you can imagine. The new measurements, published in Nature Astronomy in February 2026, revealed that Jupiter's equator is 8 kilometers narrower than our 50-year-old models predicted. Its poles are 24 kilometers flatter. And the cause? Jupiter's own winds. Previous calculations had failed to account for the full force of Jupiter's zonal winds, the powerful jet streams that wrap around the planet. These winds, invisible to the naked eye, but thousands of kilometers deep, are actually pushing on Jupiter's very shape, flattening it in ways we never understood. As Dr. Eli Galani from the Weizmann Institute put it, shifting the radius by just a little lets our models of Jupiter's interior fit both the gravity data and atmospheric measurements much better. A tiny shift, a massive implication. This isn't just about correcting a measurement. Jupiter is the oldest planet in our solar system. It likely formed first, its immense gravity shaping everything that came after, including Earth. If we don't understand Jupiter's interior, we don't truly understand how our solar system came to be. And it goes further. When astronomers discover gas giants orbiting distant stars, they compare them to Jupiter. Jupiter's size, its structure, its interior. These are the baseline for understanding planets across the galaxy. A more accurate Jupiter means a more accurate picture of every gas giant in the universe. Jupiter has been hiding this truth for 50 years. Not out of malice, but out of the simple fact that we had not yet learned to ask the right questions. Now, with Juno still orbiting with new techniques and new eyes, we are finally beginning to see the king of planets as it really is. Not smaller, not flatter, but more precise, more real. A world that still holds mysteries we have only begun to unravel.